Hi, this is Lori and welcome to my series of videos on the Pico W. This is the third part of a set of episodes focusing on exploring LED displays. In this episode, we're going to learn how to hook up an LED bar graph and use network resistors in our circuit. Here's what a LED bar graph looks like, the kind that you would get in a beginning electronics kit. And I have one of them here. It's very similar to the 7-segment display. Has little pins on it, and but no driver chips. It's really simple. It literally is just LEDs under each of these openings here, and it puts in this case 10 of them together, and in a pretty compact form. So kind of fun to play around with. And I think most people would imagine that these are used maybe to indicate amount of something, like maybe a volume display, something like that. The only thing you kind of really need to know putting these on into your circuit is what side's the anode and what side's the cathode. And sometimes you just kind of figure out that by trial and error. I have found the ones that I had in my kits, this printed side was the anode side of the LEDs. So let's get these hooked up. Now we're going to use our LED bar graph with a network resistor, or sometimes I see them called resistor arrays. I found some nice diagrams on the internet that show the different ways that this can come. I happen to have the single inline package ones, and I have them in 9-pin, and I have it in a 5-pin package. So this is one that is like this. It's a bus resistor array. So I'll have 8 resistors and then one common pin here, and then the other one has 4 resistors and one common pin. I mean, you can see that same look of the package could also be set up this way. It could be independent, where each resistor is its own thing and takes 2 of the pins to connect it together into the circuit. So you have to kind of know which one you're picking up. I've also seen people use these in projects here, the dual inline package arrays. These are kind of easier to maybe understand, that inside here, in between the 2 pins, you have a resistor. Basically, you kind of see it in this way in an electronic diagram. So there, you have to, when you get some, you have to kind of know how it's set up, so you know how to wire it. And different ones work in different scenarios of how you're going to do your wiring. But in the case of our LED bar graph, the ones I have here are going to work pretty well. And you can take a look inside here. Have some cutaways to kind of show how it works. And it uses this film element that has the resistive property inside, and it's all covered up with some kind of epoxy. So they're fun to use, and they're nice because they make it a little more simple than putting in individual resistors in. You can use these under different circuit needs and make your build really straightforward and easy. And this is the circuit we're going to use for the next couple of programs for this episode. We'll put our LED bar graph here across the divide of our breadboard. And one side we'll connect it into pins on our Pico. So we'll need 10 of those to control all 10 LEDs in the bar graph. And I'm going to use a network resistor on the other side and have that common pin connected to ground. But I don't have an object in the fritzing program that I draw these breadboard circuits in. So I just showed the individual resistors here, and they're at 470 ohm because that's the lowest resistance I have in my network resistors. So maybe a little bit more than resistance than we need, but it still works. And in the second program we'll go through, we'll use a potentiometer as though it was a volume control, and we'll use a bar graph to show when we change the potentiometer's position, we change the lights that are lit on the bar graph. Well, that's where we're headed next. Let's go check it out. Well, here's our circuit in real life. And you can see our bar graphs on here. And each of the LEDs is connected back to pins on our Pico. And then this black line here, that's the network resistor. And because I have either 8 resistors or 4, to get 10 I combined 2. So I combined a 8 resistor pack with a 4 resistor pack, and then the common pins are connected to ground for both of those. And yeah, that's it. It's a pretty simple circuit, and it is, I think, a very nice and compact way to hook up a LED bar graph when you use these network resistors. Now let's focus in here on a very simple program. We're just going to light the LEDs kind of looping around, and we'll set them up. These are the pins that I used on my Pico. And I used a simple list comprehension to set them up in a single line. I think that's a nice, nice looking piece of code there to do it very efficiently. But that's just looping through this tuple and setting up each of the LEDs as outputs. Then we'll use try and accept so that we can cleanly exit the program. And in our while true loop, we're going to loop through 0 to 9, the 10 LEDs, and toggle them on and off with a short sleep in between. And in our, when we press Control C, our keyboard interrupt, we'll just make sure they're all turned off and print done to the screen. All right, let's go ahead and run that. There we go. Yeah, so you can see it filling up. And then moving on, kind of, I don't know, like a snake going across or something. These are really fun, and I think, you know, especially as a beginner, these will be really great LED displays to start with, because you have a lot of LEDs. It's easy to set them up, and you can come up with all kinds of fun patterns that you could do with these LEDs all lined up like this. And putting 10 LEDs on a breadboard here, I mean, it's doable, but a lot of connections and easy to have something come undone when you want to work with something like 10 of them. So yeah, I think that's how this first beginning program goes, and definitely be fun to try other patterns if you're so inclined. Okay, so now we're going to use our potentiometer as a volume control, and we'll sort of display the volume on the bar graph. So you can now see that I have it hooked up to the ADC pin. And when I first did this, the way I happened to arrange my my potentiometer and how I set it to power and ground makes it work in a certain direction. And so I ended up putting the segments in a reversed order and setting them up as we did before, because that made it work. When I turned the knob, it worked the way I wanted it to. And you'll see what I mean when we demo it here. So I'll set up the potentiometer on ADC 0, and we'll use the scale function that I used previously in part 2, I think it was. It's like the map function for those who've programmed Arduinos, but it's a way to take a number in one scale and map it to a number in another. So the X will be our potentiometer scale, and the Y will be the number of the LED that we want to have on. And yeah, so when we get into our try and accept, in the while true loop, we'll read the potentiometer, then we'll scale that potentiometer value into a number between 0 and 10. So my potentiometer doesn't go down to 0 really, so I put the minimum value at 200, max at 65. Technically it could be 65, 535. And then we'll turn on all the LEDs up to that level, and then after that we will make sure the rest of those are off. And we'll use a very short delay so it's nice and responsive. Then for the keyboard interrupt, we'll just make sure that they all get turned off and we print done to the shell. All right, let's take a look at this. All right, so right now they're all off. And then when I turn it on and I bring it up slowly, you can see the LEDs coming on. And there we go. We got it maxed out. So it's all maxed out now. And as I turn it back down, they go off. So I wanted this, I wanted it to move in the same direction. And based on the way that I had it wired, I had to reverse the order of the pins. So that's fine. And depending on how you set yours up, you'll go in one order or the other. So in our next episode, we'll work with shift registers and we'll apply them to our bar graph and our 7-segment display. Hope you'll join me in the next episode. And as always, thank you for watching.